Hello, this is Mr. Stansberry. I'm going to take you through the 8C notes on factorization of quadratic expressions. So, after this, you should be able to say I can factor various polynomials. All right, so there's a lot of different examples in here, so I'm just going to get at it. And again, hopefully this should all look familiar from advanced algebra and algebra. Okay, so factorize means get common things that are common out and bring those out in front. So we're going to factor those out. So the 2x squared and the 3x both have an x in common. So one way to look at this is, I've shown people before, and this seems to be helpful, is I say, okay, I can get an x out of both of these. So I'm going to divide both of these by x. And since I'm dividing both of these by x, I'm going to put this x here out in front. So 2x squared divided by x leaves us with 2x. And then 3x over x just leaves us with 3. So this factorized is x times 2x plus 3. Now if you think about it, if you distribute this x back through, x times 2x is 2x squared, and x times 3 is 3x. So you end up getting back what you started with. Okay. So it would be a great idea on this video that at any point you feel like, okay, I think I've got this. If I were you, I would pause it before I go to the second one and then try it out on your own first and then check and see if we got the same answers. Okay, so this one here, these also both have an x in common, and then also if you'll notice 2 and 6 both have a 2 in common, so you can factor actually a 2x out of both of these. So when I divide 2x squared by 2x, the 2's reduce out and one of the x's reduce out, so we just end up with x. And then we have minus, and then 6 and 2 reduces down to 3, and then the x's reduce out. So you just get 2x times x minus 3. Okay? All right. Next set of examples. Factorize x minus 5 squared minus 2 times x minus 5. Okay, this is kind of a weird looking one, but if you'll notice, they both actually have factors of x minus 5. So I'm going to pull an x minus 5 out of both of these. So let's back up and do this. So both of these can be divided by x minus 5. All right? So when I do that, again, I pull the x minus 5 out front. And then when I take x minus 5 squared over x minus 5, that reduces one of these out. So I'm just left with x minus 5. Right? And then this x minus 5 reduces with this x minus 5. So we just have a minus 2, right? Let's see. That's kind of way too many of the wrong brackets there. Oh, there we go. So let's do this. All right. So really we can actually combine these here. So we get x minus 5 times x minus 5 and minus 2 is x minus 7, because these are all in the same parentheses here. All right, so that's what we end up with for this one. All right, on the next example here, we've got x plus 2 squared plus 2x plus 4. Now, if you'll notice, we can actually take a 2 out of both of these terms here. So we're just going to leave the x plus 2 squared alone for now, and then again, we're going to factor a 2 out of both of these. So put the 2 out front. Those reduce, and we get x. 4 over 2 reduces down to 2. And so now, if you'll look, we can actually reduce it even farther. I mean, factor it even farther, because now both of these terms here have an x plus 2 in it. Okay, so I'm going to factor the x plus 2 out of both of these, and that's going to take care of one of those, and so we still have x plus 2, and then this x plus 2 and x plus 2 reduce out, and then we have plus 2 there, so this is really just x plus 2 times x plus 4. All right. Next set of examples from page 19. Example 19 from page 247. We're going to factorize 9 minus x squared. Now, the nice thing about this is a perfect square, and this is a perfect square. And there's this nice little formula that if you have a difference of two squareds, it's going to be a plus b times a minus b. Right? So basically, what we're going to do here to factor this the nice easy way is take the square root of, since they're both perfect squares, take the square root of this, and you get 3. So 3 times 3 will give us 9, and then the square root of x squared is x. There's our x and our x. One of them is positive, one of them is negative, and that also holds true because you have to multiply together to get a negative number, so a positive times a negative gives us our negative x squared. Okay, so again, if you FOIL this out, you would get 9, and then you'd get minus 3x, and then plus 3x, which would reduce out, and then you get positive x times negative x, which is your negative x squared, so you get your 9 minus x squared. Okay, b is also a perfect square minus a perfect square, so I'm just going to take the square root of both of these. Square root of 4 is 2, square root of x squared is x, and then the square root of 25 is 5. So 5, 5, 1 is positive, 1 is negative. Okay, that's just a nice little difference of squares problem. Okay, all right. Next next example is example 20 from page 248. We're going to factorize 3x squared minus 48. So first thing to notice is both of these can be evenly divided by 3. So we factor the 3 out. Those 3's reduce out, and we get x squared. And then negative 48 divided by 3 gives us 16. All right? And then if you'll notice here again, we've got a perfect square minus a perfect square. So we have 3 out there, and then the square root of x squared is x. So we go x times x. Square root of 16 is 4. So 4 times 4. And again, one of these will be positive, one of these will be negative. So that's this thing all factored out. All right? All right, we're getting there. So next example, page 248, example number 20. We're going to factorize into linear factors. Okay? So what we're going to do, on these here is we're just going to factor these things out as best we can. Okay, which if you'll notice, 11 is not a perfect square, but what we're going to end up doing is you can take the square root of 11 is a perfect square, and that gives you 11. So what you can do on this is still do your difference of squares. So you do x times x to get the x squared, and then again the square root of 11 is just square root of 11, and then you can put one positive and one negative. All right, and those are our factors. Okay. Excuse me. Same thing here. This is a perfect square. This is not a perfect square, but we can just turn it into the square root of 5. So we're going to have, I'm going to make these a little bit bigger because we're going to have to fit x plus 3 into the front of both of those, because the square root of x plus 3 squared, the square and the root reduce each other out, and you get x plus 3. So that's why we get x plus 3 for the first terms, and then again we'll get square root of 5, square root of 5, one's positive, one's negative. Those are that's this thing factorized. All right.